This is what the slide would look like if you had an inherited retinal disease. Good morning everyone, my name is Nicholas Ponticus and I'm a researcher at the UCL Institute of Ophthalmology and Moorfields Eye Hospital, where I specialize in the genetics of inherited retinal diseases. My proposal, Eye2Gene, is to develop a machine learning powered web tool to streamline the genetic diagnosis process to make it more efficient and accessible. Inherited retinal diseases are the leading cause of visual impairment in the working age population in the UK, and they affect over 25,000 individuals. There are diseases caused by mutations in a single gene, for instance here the Eye2A gene, which lead to cells at the back of the eye, the retina, to deteriorate, leading to visual impairment. Identifying the genetic mutations causing the disease in a specific patient, also known as a genetic diagnosis, is crucial for the care and management of the patient, and in particular for advising the patient on their family planning, for informing the patient about their prognosis, and for directing the patient to ongoing gene treatments. However, there's currently a number of limitations to the current genetic diagnosis process, namely that it's expensive for the NHS, it takes a long time, it's only available at a limited number of specialist centres in the UK, and a lot of patients to this day do not have a genetic diagnosis even at the leading centres. So I aim to address these issues with Eye2Gene and to make the genetic diagnosis process more efficient, so more cost effective, more accessible, and for more patients in the UK to have a genetic diagnosis. So I aim to achieve this using machine learning trained on the unique dataset at Moorfields Eye Hospital, which is one of the largest inherited retinal disease datasets in the world, and to use machine learning to emulate the three work streams used in the genetic diagnosis process, namely from imaging data, from clinical data, and from genetic data, and to combine the outputs of these three work streams to obtain a consensus genetic diagnosis. So in my first year, I'll be working on obtaining a genetic diagnosis from retinal images, and for that I will be using the retinal images from patients with a known genetic diagnosis. As you can see on the right here, the labels are the gene names, and I'll be using this to train a deep learning neural network so that given a new retinal image I can obtain a genetic diagnosis probability. And this functionality will be made available on the Eye2Gene web interface at the end of the first year. And in my second year, I'll be extracting clinical codes from the clinical records, as you can see here in yellow and in blue, and I'll be using these to train a machine learning approach known as random forest, so that given some clinical codes I can obtain a genetic diagnosis probability. And this functionality will be made at the end, will be made available on Eye2Gene at the end of my second year. And in my third year, I'll be combining the clinical symptoms with the genetic data, and I'll be using the Phenopolis platform I've developed in order to obtain genetic diagnosis probabilities, but this time at the level of individual mutations. Combining the outputs of these three work streams, I'll be taking the genetic diagnosis probabilities obtained from these three different work streams, and I'll be combining these to obtain a consensus genetic diagnosis, as you can see here in green. And this will present the fully functional version of Eye2Gene, and will be made available as a web interface where users can just drag and drop their data and obtain a genetic diagnosis probability. There's a demo available at this address. My training and development plan is going to involve developing my skills in clinical ophthalmology and text mining at UCL and the Fire Institute, as well as key research visits at labs that wish to collaborate with me on Eye2Gene. And I'll be presenting and networking at genetic and ophthalmology conferences, as well as patient public research days. Eye2Gene is going to give a genetic diagnosis for male patients earlier, which is going to mean better support and more opportunities for treatment. It's going to facilitate research and improve care by streamlining the genetic diagnosis process, and it's going to save costs for the NHS, as well as give opportunities for international collaborations through the web interface. It will also in the future possibly serve as a screening and educational tool for opticians and a platform for public involvement. And for me, the fellow is going to be a unique chance to develop my skills in informatics and artificial intelligence applied to healthcare, and to establish myself as a future leader within the NHS. And finally, I'll leave you with some of the insightful patient feedback I've had from a charity-run workshop. Thank you very much.